Hey y'all, welcome to this video where I will be explaining to you guys the fundamentals of electrolysis. Alright, this is the first slide. Let's get to the next one. We have the focus questions. How do electrolytic cells use energy to drive non-spontaneous reactions? We will get to know that sooner on in the video. New vocabulary, we got two new vocabs, electrolysis and electrolytic cell. Now we have redox reaction. From the name re, it's reduction, and red reduction, oxidation. So it's an oxidation reduction reaction. Recall, oxidation is a loss of electrons and reduction is the gain of electrons. So when something gains an electron, it is reduced, and when it loses an electron, it is oxidized. Reversing redox reactions. The use of electrical energy to bring about a chemical reaction is called electrolysis. So as you can see here, we have a voltage cell in the electrolytic cell. This is the voltage source, the electric energy that we need to transfer to chemical energy that we need for this reaction of electrolysis. Now, an electrochemical cell in which electrolysis occurs is called an electrolytic cell. This is the electrolytic cell. It is a cell that uses electrical energy, transfers it to chemical energy by electrolysis and using the terminals, positive and negative, and it is basically the reverse of the voltaic cell. So voltaic cell, it works normally. You have a reactive element, zinc, and a less reactive element, copper. Zinc is more reactive, and here it is oxidized because it's more active, and this is a spontaneous reaction. It loses the electrons, and the copper is less reactive, it gains the electrons. And as you can see here, you got the chemical source. The zinc deteriorates, the copper does not. And now for the reverse reaction, this is the anode, the copper is the anode. Here the zinc was the anode, and the copper is the cathode. Here the copper is the anode, which is the oxidized part, and here this is the cathode, because this electrical energy forces it to do the opposite, the reverse reaction, because we have the voltage source, forces it to do the non-spontaneous reaction. You got electrolysis of water. Electrolysis of water is one method of obtaining hydrogen gas for commercial use. So they use electrolysis of water because they want to extract hydrogen, because hydrogen does not exist in nature. You need to use water. You need to extract it from water. H2O is the normal one, and we take the hydrogen gas by electrolysis. Electrolysis can separate molten sodium chloride into sodium metal and chlorine gas in a chamber called a down cell. So here, as you can see, the down cell, this is the inlet, the NaCl, the molten one, it goes in, and here it is, and the chlorine as well, and they go through using the voltage source. The reaction happens involving an iron cathode and an iron and carbon anode, and this is the iron screen. The chlorine goes out when it was molten. Now through the output we have chlorine as a gas, and from here the outlet, the Na, we have it as a liquid metal. Alright, on to the next one. In the decomposition of brine, an aqueous solution of NaCl, brine is an aqueous solution involving water, of NaCl, electrolysis is used to produce the hydrogen gas through electrolysis in an aqueous solution of in the decomposition of brine. Now it produces the hydrogen gas, chlorine gas and sodium hydroxide. Commercial facilities use an electrolytic process to obtain hydrogen gas, chlorine gas, and sodium gas from brine. As you can see here, you have the anodes here and the cathode ion permeable membrane. Brine goes in, deplete brine out, water and NOH out. There we go. Now, there's as you can see, the sodium hydroxide, we have it here, and we got the depleted brine, and Cl and hydrogen is produced, all through the beautiful power of electrolysis. Now we got applications of electrolysis. What is it used for? The whole Herald process requires large amounts of energy, which is the primary reason for recycling aluminum. Well, because when you want to make the whole Herald process, you find out that it needs a lot of energy. So in order to save all that work and save our resources, we recycle aluminum. Here, as you see, the carbon anode, you got carbon and two oxygen molecules, negative charge. Now it becomes it's aqueous. Now after the process, it becomes carbon and it loses 4 electrons. As you can see here, electrolysis happens with the aluminum. Now, applications of electrolysis. We got more. Objects can be electroplated with metals as silver. The cathode is the object to be electroplated where reduction occurs. The anode is a bar of silver where silver is oxidized and silver ions are transferred to the cathode. So the cathode, the one that is negatively charged, it's the one that is electroplated, metals like silver. And the anode is the bar of silver, where silver is oxidized and silver ions are transferred to the cathode. As you can see here, we use a battery as a volt source for this reaction. This is actually how it powers up our things. Here, when the charges they keep flowing, this is how the devices are powered when you put a battery. Which now I have a quiz. Okay, alright, now we go on the slideshow. Okay, slideshow. Which is the use of electrical energy to bring about a chemical reaction? Is it reduction, galvanization, which is another name for what is it called? Voltaic reactions, and electrolysis or oxidation. Alright, I'll give you 3 minutes. I'll give you 1 minute. And time's up. If you picked reduction, I'm sorry, you're wrong. If you picked oxidation, you're wrong, I'm sorry. Galvanization, no. And if you picked C, electrolysis, then you, my friend, was paying attention. That is the right answer. Okay, so we use the electrical energy, just as I said, through the voltage source to bring the chemical reaction. Use the electrical energy for the chemical energy. That's electrolysis. Now, which is an electrochemical cell? Which electrolysis occurs? fuel cell, a half cell, or a voltaic cell? I will give you guys 30 seconds. And time's up. If you answered voltaic cell, you're absolutely wrong. But if you picked fuel cell, I'm sorry, but you're also wrong. Half cell, it is definitely not the right answer. Sorry. But if you picked an electrolytic cell, which an electrochemical cell, which it electrolysis occurs, then you is right. Good job. Electrolysis can separate sodium chloride into sodium metal and chlorine gas into a gas chamber called downcell. What can it separate? I will give you guys 30 seconds. And time's up. If you picked solid, I'm sorry, you are wrong. If you picked dissolve, then I'm sorry, but it's not right. If you picked gaseous, good attempt, but you're not right. But if you picked molten, then congrats, that is the right answer. Now, we got another question. Question 4. In the decomposition of brine, electrolysis is used to produce what? A. H gas, chlorine gas, and NaOH aqueous, or H gas, chlorine gas, O2 gas, and sodium, or hydrogen, water, and NaC, sodium chloride, or water and sodium chloride that is solid, the other one's aqueous. Alright, I'll give you guys 30 seconds, think about it carefully. And 30 times up. If you picked B, you're wrong. I'm sorry. Pick D, I'm sorry, but you're wrong. But if you picked C, though, you're wrong. Alright, the right answer was A. H, we are extracting from the brine, which is NaCl. We take from it the chlorine and the hydrogen and the NaOH because because it's aqueous and we're using water. Which 5, which occurs where an object is electroplated. This is a hard one. Alright, I'll give you guys 30 seconds. 1. And time's up. If you picked D, sorry, you were wrong. If you picked A, you were wrong. If you picked C, you were wrong. And the answer is B because when it's electroplated, as we said, this is the cathode. which is negatively charged, and when it's negatively charged, the electrons are gained and electrons are gained. That is reduction. And that was it, guys. Thanks for watching, and I hope you guys learned today about electrolysis, its applications, and how it works. If you guys like this video, please like and subscribe, and leave a good comment, and goodbye.